Historically, aerospace giants operated on a simple rule: move slowly, divide the government contracts, and aim for absolute engineering perfection before a rocket ever touches the launch pad. In May 2026, we saw exactly how that conservative approach holds up in modern aerospace. During a static fire test, the final step before an actual launch, Blue Origin's New Glenn rocket detonated on Launch Complex 36, creating an apocalyptic orange fireball visible 100 miles away. Exactly 12 hours later, from a pad at the exact same Cape Canaveral facility, SpaceX launched 29 Starlink satellites into orbit. The contrast reveals a deep philosophical divide. While Blue Origin remains stuck in early testing phases chasing absolute perfection, SpaceX built a launch machine around a launch fast, learn faster methodology. By absorbing early failures as data, they achieved over 120 launches in 2026 alone, with a 98% success rate. That operational speed translates into market dominance. On the same day they launched those 29 satellites, SpaceX secured a $4.16 billion contract with the Pentagon. This animation shows exactly what that contract, known as Golden Dome, requires. Instead of traditional static surveillance, SpaceX is building a network of satellites in low Earth orbit designed to detect and continuously track fast-moving hypersonic missiles across the globe. SpaceX has transitioned from a commercial launch provider to the primary gatekeeper for American space defense, now holding over $6 billion in total Space Force contracts. Down at the localized hardware layer, monopolies look different. For an entire decade, Qualcomm has held complete control over the Windows on ARM processor market, maintaining high prices despite offering mediocre performance. That control is ending at Computex Taipei. In a highly coordinated counterstrike, Nvidia, Microsoft, and ARM are teaming up to release the N1X processor. The N1X architecture packs two distinct powerhouses into a single package. On one side, 20 MediaTek CPU cores. On the other, 6,144 CUDA cores, delivering RTX 5070 equivalent graphics power. This chart visualizes what that layout means for the user. When you compare raw graphical output, the Nvidia N1X towers exponentially over Qualcomm's mid-range Snapdragon X Elite. For the first time, a Windows on ARM laptop can handle heavy 3D rendering and AAA gaming. This alliance strips Qualcomm of its pricing power and signals a shift for high-performance laptops. By proving ARM architecture can sustain workstation-level graphics, Nvidia and Microsoft are moving into territory long guarded by Intel and AMD. Hardware monopolies are broken with superior architecture. Software and entertainment monopolies, however, are built on inescapable market gravity. In May 2026, Microsoft announced that its highly anticipated first-party game, Fable, would be delayed by a full year to early 2027, officially citing a crowded holiday window. The actual reason for the delay is GTA 6. Rockstar's upcoming release acts as a black hole on the gaming industry calendar. With projections of over 100 million copies sold in its first week, it commands all media, streamer, and gamer attention. Even a trillion-dollar company like Microsoft will clear its release schedule rather than compete for oxygen. We see a different kind of software gravity forming at OpenAI, which is attempting to turn ChatGPT into a daily multi-purpose super app. Their new mobile feature allows developers to remotely launch and manage Codex coding tasks on their Windows PCs entirely from an iPhone or Android device. A developer can start a complex coding project from their phone while commuting, track its progress, and approve the final code before they even reach the office. Whether it is through the unavoidable cultural mass of a Rockstar game or the deep workflow integration of an OpenAI assistant, the ultimate software monopolies secure their position by dictating exactly how users spend their time. While the battles for aerospace defense and silicon supremacy happen in plain sight, the most dangerous shift in power is happening invisibly. The cryptographic systems protecting global digital infrastructure, like RSA and ECC algorithms, rely on math problems that take classical computers millions of years to solve. Quantum computing threatens to render those locks useless. This visualizes a recent finding from Google Quantum AI. A quantum computer with 1,200 logical qubits possesses the mathematical power to derive a Bitcoin private key from its public key in just 9 minutes, roughly the time the Bitcoin network takes to confirm a block. The immediate reaction is to worry about future attacks on cryptocurrency wallets. But cybersecurity experts like Andrew Galt warn that the true threat is an intelligence strategy known as harvest now, decrypt later. As this graphic shows, attackers don't need a functioning quantum computer today. They are actively intercepting and stockpiling encrypted SWIFT interbank messages and crypto authentication records right now, hoarding the data in secure vaults until quantum technology matures in the 2030s. This strategy rewrites the security timeline. Because intelligence agencies are building libraries of today's secrets, the exact moment a 1,200-qubit machine turns on, a decade of stored financial and private data becomes transparent. The turning points of 2026 show that market leaders are no longer protected by traditional moats. Across orbit, silicon, and cryptography, survival now depends on moving faster than the next decryption cycle.